All right, let's just jump right in. Have you ever seen those straight vertical bars around a number in a math problem and just thought, what in the world is that about? Well, we're talking about absolute value equations. And yeah, they can look a little weird, but I promise you, by the end of this quick explainer, you're going to see they're based on one super simple idea.
But first, let's start with a little puzzle. Imagine your friend says they have about $50 on them, give or take $15. So, what's the most money they could actually have, and what's the least? Just keep that question tucked away in the back of your mind, because the math we're about to cover is going to give you the perfect tool to solve it.
So, what even is absolute value? Well, the official definition is just a number's distance from zero on the number line. That's it. Seriously, it has nothing to do with being positive or negative. It's just about pure, simple distance. Think about it like this. If you walk 2 miles east to get to a store, the distance is 2 miles. If you walk 2 miles west to get back home, the distance is still 2 miles. The direction changed, but the distance didn't. Absolute value only cares about the how far, which means the answer is never, ever going to be negative. Okay, so with that in mind, quick pop quiz. What's the absolute value of -8? Or, in other words, how far is -8 from 0 on that number line?
Yep, you got it. It's 8, because -8 is exactly 8 units, or 8 steps, away from 0. And what about +8? Well, it's also 8 units away. They're on opposite sides of 0 for sure, but they have the exact same distance, the same absolute value.
And you know what? That simple idea right there, that is the secret to cracking every single one of these equations. The moment you realize that absolute value is just asking a question about distance, the whole thing just clicks.
So when you see an equation that says the absolute value of x equals 8, it's not really asking, what is x? It's asking a much cooler question. Hey, what numbers out there in the universe are exactly 8 units away from 0?
And as we just figured out, there are 2 of them. +8 is 8 units away, and so is -8. This is the big takeaway, the crucial point. An absolute value equation almost always splits open into 2 separate paths, giving us 2 possible solutions we need to track down.
This whole idea leads us to a simple 3-step method that you can use every single time. Step 1, you have to isolate the absolute value part of the equation, get it all by itself. Step 2, you split it into those 2 paths we were just talking about. And finally, step 3, you solve both of those new, simpler equations. Just burn it into your brain. Isolate, split, solve.
Okay, let's put this machine to work. Let's try this one. The absolute value of 3k plus 8 equals 2. Now, what's our first step? Isolate, right? Well, in this case, it's already done for us. The absolute value part is all by itself on one side of the equation, so we get to jump right to step 2.
Time to split. This means that the stuff inside those bars, the 3k plus 8, well, that could be equal to +2, or it could be equal to -2. Why? Because the absolute value of +2 is 2, and the absolute value of -2 is also 2. See? We've just created our 2 distinct paths to follow. And now for the easy part, step 3, solve. If you follow that first path and solve for k, you get -2. If you follow the second path, you get k equals -10/3. And boom, just like that, you've got 2 different answers from that one original equation. It really is that simple. Isolate, split, solve.
All right, so you've got the main method down pat. But there are a couple of common traps that a lot of people fall into. The good news is, if you know what to look for, you'll see them coming a mile away.
So, what happens if you run into an equation like this one? It looks pretty normal at first glance, but we got to remember the rules. What was step 1 again? That's right, isolate. We absolutely have to get that absolute value expression all by itself before we do anything else. So, we subtract 4 from both sides and get rid of that negative sign, and we're left with this. The absolute value of 5w plus 3 equals -1. Now, just take a second and look at that. Does anything seem a little fishy?
And that right there is the trap. This equation has no solution. Full stop. The second you see an isolated absolute value equal to a negative number, you can just stop working. And why is that? Well, remember what we said absolute value is? It's distance. And you can't have a negative distance. It's just impossible. So if you ever do the work to isolate an absolute value and see it equals a negative, you know you found an equation with no answer. It's a dead end. Okay, here's the second special case you might see. What if the absolute value equals 0? Do we still need to split it into two paths, one for positive 0 and one for negative 0? Is that even a thing?
Nope. Think about it. There's only one number on the entire number line that is 0 units away from 0, and that's 0 itself. So there's no need to split. You just drop the absolute value bars, solve the one equation that's left, 3x plus 12 equals 0, and you find your answer. X equals negative 4. Just one single solution.
Okay, so you are now armed with all the knowledge you need. Let's go all the way back to the beginning, back to your friend with the fuzzy wallet math. They've got 50 bucks, give or take 15. Let's solve this for good. We can actually translate this real-world problem into a perfect absolute value equation. Let's say X is the actual amount of money they have. The difference, or the distance, between that actual amount X and their guess of 50 is 15. See how perfectly that fits?
The absolute value is already isolated, so it's time to split. Path 1 is the give path, where the difference could be a positive 15. Path 2 is the take path, where the difference could be a negative 15.
And once we solve both of those simple equations, we get our answers. On the high end, they could have $65, and on the low end, they might only have $35. And just like that, we've used an absolute value equation to figure out a real-life situation. Pretty cool, right?
So when you really think about it, this whole time we've been mastering the idea of distance on a simple one-dimensional number line. But that kind of brings up a bigger question. What happens when we move off that simple line and onto a two-dimensional flat plane? How do you find distance then?
Well, that exact idea actually has a name. It's called the modulus. It's basically the absolute value for complex numbers. It's how you find their distance from the center point on a 2D map. It's a fantastic example of how this really simple concept of distance just keeps growing and scaling up into much more advanced math. It even connects to finding the length of a triangle's side, but that's a story for another time.